Today we are going to talk about improper fractions and I guess mixed numbers and how we can demonstrate improper fractions with models. So an improper fraction is a fraction that the numerator or the top number is bigger than the denominator. So all three of these are improper fractions because the top number is bigger than the denominator. And this means that the improper fraction is more than 1. And I will show you why that is true. But anytime the top number is bigger than the bottom number, it equals more than 1. So, what the bottom number represents is thirds, right? So, in 5/3, this top one here, what the bottom number represents is how many pieces we split a whole into. So, if I draw this circle here, I know that I'm splitting it into thirds. Okay? So, I am splitting this into thirds. So I'm just going to mark each of these 1, 2, and 3. Let's say that I filled those in. So now the top number, the numerator, is how many thirds that I have. So I have filled in 3/3. So this is equal to 3/3, which equals 1, right? I filled in this whole thing. Now, I need to fill in 2 more thirds, right? Because I have 3/3, and then I need to fill in 2 more thirds for 5/3. So, that would be 1 and 2, okay? So, I have now filled in 5/3. So, since 3/3 equals 1, 5/3 can also be expressed in a mixed number, which would be 1. So we have 1 right here in this, right? And then we have 2 more thirds. So 5/3 equals 1 and 2/3, as you can see. Now, let's go to 4/2. So I know that since the 2 is on the bottom here, that means that I have to split the whole, right? Each of these circles is a whole. I have to split this whole into halves, or 2, right? So now I'm going to color 2 of them, right? I'm going to color both of them because it says that there's 4 in the numerator. So we need to shade 4 of them. So I shaded 2 of them, and then we need to keep drawing circles until we can get to 4. And now shaded 3, and now 4. And like I said, okay, so this is 2/2, which equals 1, and this is 2/2, which equals 1. So 4/2 actually equals 2 because I filled in 2 holes here. So 4/2 actually equals just 2 holes. That's it. So now we can go into 7/4. So I don't need to draw circles. I can also draw squares, rectangles, anything. But I know that I'm splitting it up into fourths because that's the denominator. That's the bottom number. And the bottom number tells us how many pieces, even pieces, equal pieces, we're splitting the fraction into. So this is 1, 2, 3, 4. Now we have to draw another one also split into fourths, okay? And we have to fill out, we've done 4 fourths, right? And anytime the top number and bottom number are the same, it equals 1, right? Because it means that we're splitting it into 4 pieces, and then you have 4 pieces, right? So the bottom number means we're splitting it into 4 pieces, and the top number means we have 4 pieces. So anytime it's 4 over 4 equals 1, and now we have 3 left. We have 3 pieces left to get to 7, right? So we have 4 fourths, and now we need 3 more pieces to get to 7, right? We can count these, and now we have 7 pieces filled out, and this is 3 fourths over here. And so 7 fourths actually equals 1 and 3 fourths. And let's say this was, instead of 7, let's just say this was 9 fourths, just to give you an example. And I would do 8, so this would be 7, this would be 8, and this would be 9. And then in this case, this would also be 4 over 4, which equals 1, and this would be 1/4. So 9 fourths would actually equal 2, because we have 2 full, 2 wholes, and 1/4. So hopefully that kind of gives you an idea of how mixed numbers can become, how they work, and how they can become, how improper fractions can become mixed numbers through models.